In this video, I will show you how to write the standard form equation of a hyperbola given certain information like the foci and the vertices, or the vertices and the asymptotes. Now we know that every hyperbola equation has a fraction minus a fraction equal to 1. To get a better handle on what's going on, we should definitely graph this stuff. So let's see. The foci are at 6, 0 and negative 6, 0. Let's sketch that. So 6, 0 and negative 6, 0. These are the foci. Okay. Right away that tells me two things. Number one, it tells me that I'm dealing with a hyperbola that is opening left and right. Alright, because it has to curve around these. So this is a horizontal hyperbola. That means that in my fraction, the x term is going to be first. There's going to be some kind of an x expression here. Also, I know that the center is 0, 0, because it's got to be right in the middle between these two foci. So the center is 0, 0, and it's horizontal. That's enough information right there for me to know that this is going to be x squared and this is going to be y squared. It's x squared and y squared because of the 0, 0. The x squared is first because it's horizontal. So now all I need is a squared and b squared. Let's keep going. The vertices are at 4, 0 and negative 4, 0. Let's graph that. So the vertices are at 4, 0 and negative 4, 0. Alright, which tells us that the hyperbola is doing this type of thing. Okay, but anyway, I'm just having fun drawing this picture. But in terms of the equation, I now have the a value because the distance from the center to a vertex is the a value. So a is 4. That means that a squared is 16. Because this is horizontal, this 16 definitely goes with the x term. It just makes sense. So I'm going to have 16 right there. Okay, I still need to find b. I cannot find that directly because I don't have the covertices. But what I do have is the c value. They gave us the foci. So look right here. The distance from the center to a focus, that is c. So they gave me that distance is 6. So I know that c is 6, which means that c squared is 36. Now, let's work out this equation. Okay, because we know that c squared is equal to a squared plus b squared for hyperbolas. C squared is 36, a squared is 16, plus b squared. So all I have to do is subtract 16 from both sides. And then I have b squared. So this is going to be 20. So b squared is 20. Alright, that means that the other denominator must be 20. And that's it. We found the standard form equation for number 4. For number 5, we are given that the foci are at 0, 8 and 0, negative 8. Let's sketch that. We have foci at 0, 8 and 0, negative 8. The vertices are at 0, 7 and 0, negative 7. Okay, vertices here and here, which means we have a vertical hyperbola going like this. Okay, so that tells me a couple of things. The center is 0, 0, because it has to be right in the middle. Because the center is 0, 0, I'm just going to have x squared and y squared. Because it's vertical, that tells me that the y term is going to be first, because that's what always happens when the hyperbola is vertical. So it's always a fraction minus a fraction equals 1, but the numerator will be y squared and x squared because the center is 0 and 0. So I won't have x minus 3 or anything like that. Now all I need is a squared and b squared. Well, a squared is just the distance from the center to a vertex. So, well, the a value, not a squared, but the a value is the distance from the center to a vertex. So this is a. A is 7. That means a squared is 49. See how it's vertical? So it makes sense that this 49 is going to go under the y term. 49. Kabam. Now, that's a squared. Now I need b squared. I don't have b squared in the picture, but what I do have is c, because the c value is the distance from the center to a focus. Okay, that is the c value. So c is 8, which means that c squared is 64. That will help us find b squared, because in a hyperbola the relationship goes c squared is equal to a squared plus b squared. So c squared, whoops, we know what c squared is. So 64 is equal to 49 plus b squared. So if we just subtract 49 from both sides, that gives us that b squared is equal to 15. So that means that right here I'm going to have 15. Alright, because that's b squared. And that's it. This is the standard form equation for number 5. Alright, take a look at the information we're given for number 6. With these radicals in here, it may be useful to know the decimal approximation. So negative 2 radical 5 is approximately negative 4.5. And of course 2 radical 5 is approximately 4.5. So we have foci at 0, negative 4.5. and 0, 4.5. So those are the foci. We have vertices at 0, negative 4 and 0, positive 4. Okay, so vertices here and here, which means that our hyperbola branches, which wrap around the foci, are opening up and down. Okay, this tells me two things. Number one, the center of the hyperbola is here at 0, 0, which means that when I make my equations, I will just have numerators x squared and y squared instead of like x minus 3 squared or anything like that, because it's just a 0. Also, because this is vertical, the y squared will go first. So my equation is going to start off like this. I will have y squared over something minus x squared over something is equal to 1. Now I just need a squared and b squared. Well, the a value is going to be the distance from the center to a vertex. So that means that the a value is 4, which means that a squared is 16. So my first denominator here will be 16. Now I need the b squared. Well, I don't have the covertices, so I can't find it in the same way. But what I can do is use the c value that I can find. The c value is the distance from the center to a focus. So that tells me that c is, well, wait a minute, what was this again? This is between the lines. I kept calling it 4.5, but really it's 2 radical 5 to be exact. So that means my c value is 2 radical 5, which means that c squared is going to be 2 radical 5 squared. So how do I square 2 radical 5? Well, if I square the 2, I get 4. If I square the radical 5, I get a regular 5. So this is really 4 times 5. C squared is 4 times 5, which means that c squared is 20. But I don't really care about c squared. What I really want is b squared. But what I know is that c squared is equal to a squared plus b squared for hyperbolas. So c squared is 20. A squared is 16. So plus b squared. So if I just subtract 16 from both sides, that's going to tell me that b squared is 4. Look at that. So b squared is 4. And that's it. This is the standard form equation for number 6. As we glance at number 7, it might be useful to think about the decimal approximation. Well, actually, it's not an approximation. 5 divided by 2 is exactly 2.5. So that makes this negative 2.5. So we have foci at 0, 2.5 and 0, negative 2.5. So that means that the foci are here. Boom and boom. We have vertices at 0, negative 2 and 0, positive 2. Okay, so these are my vertices, which means that I will have branches of this hyperbola which wrap around the foci, opening up and down like this. So, because this is vertical, that tells me that the y term will be first and the x term will be second. Because of symmetry, I know that the center is going to be at 0, 0, right in the middle of this, which tells me that it will just be y squared and x squared. There won't be any y minus 3 squared or anything like that because it's 0. So I'll have y squared and then x squared. So let's go ahead and start to build our answer. So we should have y squared over something minus, and then we'll have x squared over something, and it's always going to be equal to 1. So I need the a squared and I need the b squared. Well, I can find a squared very easily because the a value is just the distance from the center to a vertex. So a is 2, which means that a squared is 4. So that gives me the first denominator. A squared is 4. Now all I need is b squared. I do not have the covertices, so I cannot find b squared directly. But what I can find is c, and therefore c squared, because c is the distance from the center to a focus. And remember, this distance is 5 over 2. So that tells me that c is 5/2. That means that c squared is 25/4. I just squared both of these. So I have a squared and I have c squared. What I really want is b squared, so I have this denominator right here. So what I'm going to have to do is remember that c squared is equal to a squared plus b squared. So c squared, that's 25 fourths. So 25 fourths is equal to 4 plus b squared. So now I just need to subtract 4 from both sides. So now I've got 25 fourths minus 4 over 1. And that's equal to b squared. Well, what now? I need like denominators. So I'm going to multiply by 4 like this. So now I'm going to have 25 fourths minus 16 fourths is equal to b squared. 25 minus 16, that's going to be 9. So I'm going to have 9 fourths, and that's going to be b squared. And that's all I needed. 9 fourths, man. I really don't like having a fraction inside of a fraction, but for standard form, I feel like this is what we have to do. If you don't like having a fraction inside of a fraction, you could write the equation this way. Instead of 9 fourths, we could put the decimal 2.25. This is exact. It's not rounded or anything, so there's no reason why that wouldn't be okay. So anyway, that's it for number 7. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.